Okay, let's talk about the station point now. And what we need to do is explain how can the station point be something that's out front here where our actual position is in front of this diagram at our true eye level, center of vision, at a true, particular distance, always right between our eyes. That's us looking in. This is my true station point right here. Also, though, because of the abstract needs of the geometry for perspective, we can flatten the idea of the station point. So the SP, that black box that is X'd, station point, with the cone of vision 30 and 30 degrees, 30, 30 equals a total of 60, going to the marcation of the cone of vision. It turns out that if we simply take a flap and flatten what was this distance down to that flap, we can measure all the exact same real angles as we could from our actual head. We can't show our head because that's three-dimensional, and we're working on a two-dimensional surface. So in order to make that abstraction, it's simple. The idea that you can flatten it but still have the real same angles coming and striking the picture plane eye level are the same angles striking at the same place on the picture plane eye level as if we were standing out here from my head. So just in short, to begin, let's just take the two angles coming off of the cone of vision that come out at 30 and 30 from the flattened flap representative station point there, coming up, as you can clearly see, and striking at their points where we begin the cone of vision. The cone of vision was drawn like a compass out and around from the center point, equal distances. The idea is, 30 and 30 for a total of 60 strike there. Well, it turns out that if I struck those exact same angles from my standing station point right here between my eyes, the exact angles would also strike the picture plane and continue on forever as 30 and 30 degree vanishing points, because not only does those strikes against the picture plane, not only do they represent where we're drawing our cone of vision, but remember, our cone goes on forever as a growing and growing and animating cone. It goes forever. Therefore, that strike against the picture plane at 30 and 30 degrees for a total of 60 actually is analogous exactly to vanishing points too. And in that case, because I can actually cast real angles from the flattened station point, it turns out I can cast those exact same angles from my real space, three-dimensional space head also, and they strike exactly at the same place on the picture plane and then go on forever. So the difference is here, they have to come up to the picture plane and turn in and go on into the picture and go on forever to represent vanishing points or the illusion of them, okay? The difference is with my head, I don't need to do that. They just come straight off my head at those same angles, and they go on forever to become the vanishing points. They just go straight, they strike the picture plane eye level, and they continue in forever. The difference here, again, from the flattened flap of the SP is that they have to come up, strike the picture plane eye level, then turn and go into the picture. So they're coming up and then going boom into the picture. There's no difference, though. As far as the business of actually measuring real angles from the single station point, the viewer, the operation is exactly the same. So once again, striking these same real angles projected off my head, striking the picture plane eye level, is the same thing as doing it from here at those exact same angles coming up, striking in and going into the picture. So it's the same. I'll use this curtain rod magical wand thing, and I'll demonstrate the idea. So it's like a hinge. I'm actually standing here where my station point is. So here's remember my distance line again, my first distance line right here. That's exactly me looking into the picture, right? This entire flap, including the angle of the cone and even some vanishing points in a very large flap, it doesn't matter, can all be taken down with this as the hinge point, the eye level picture plane, and it can be turned down, and that exact distance is the station point flat. And the idea, because that whole thing can be flapped down as a hinge, we can get all the real angles we require to our angle of vision because this represents us from above. So I'm really here looking in. But also we can be looking at ourselves in third person as well as in first, and I'll explain that in a second. So this view of the station point is actually the distance we are to the picture plane. It's just that this is the top of the picture plane and it's flat and thin, just like this picture plane at the top or up here is flat, like a flat piece of glass. So once again, we're looking at both into the picture as the first person, like this, I am the first person in my own story looking into the view, but when I'm actually looking at the flap down and looking at the flattened SP person, me looking into the picture or us, I'm now the third person observing myself looking into the picture, but there is there's no height to it. It's just a flattened out plan view, basically, of real angles going to my station point. But that's exactly, in future diagrams very quickly, where we actually get real angles to project into the perspective. But I want to be really clear and not draw anything in this circle until we understand the parameters of this stuff. The reason I'm not showing any really nice perspective drawings or anything complex, and look at this incredible perspective, isn't it beautiful? Yeah, great. But the idea is we want to learn why this works. And all we're saying is, yes, I could draw a little mountainscape here for the horizon and a desert on the salt flats of Utah, or rolling hills and a pagoda or something. Fine, we all know that. That's in the picture plane. It's the window. Remember, the picture frame is the off-white paper. Fine, we all get that. That's pretty easy to remember. Like, I could look into this picture and see any kind of view we want. What most people don't get is that our actual position to the picture plane as a real viewer in 3 dimensions can be represented equally by taking this flap and making it 2-dimensional. And then, therefore, this station point we're going to see over and over again in our diagrams. We'll explain it. We're going to use it through the whole course. You can even use this for fast thumbnails. You can do a window, flap in these parameters just by freehand, and you will know, you'll make your pictures look much more real, much quicker, because you're actually using the real angles we actually see at when we're standing out here, and it's really helpful. So even though it's kind of an arcane point, I wanted to still keep this diagram blank and make sure you understood that the real us standing out here at the station point with the distance line going right between to the red dot, that is this distance, again, can be abstracted and flattened out like an entire flap down like this to become that station point. And the whole flap can be carried with it because the hinge point is the picture plane eye level. Why? Because that's where we are standing from at the height we're seeing. Because we're the viewer, that's why it flips down at that point. All you have to do is have faith that it works and understand it generally. The big thing is that it greatly helps us set up a picture really quick, even in casual drawing all the way to fully measured drawing. So that is the explanation of the station point. And I wanted to make the point again, if I went over it a little too quickly before, is that the eye level, the center of vision, the station point, and the projected cone of vision, again, are ours. We own them. They're always with us, as I pointed out before. No matter where we go, that package of 4 items is always with us on our heads like permanent headgear. The rest of the things we look at, like the horizon line where the earth meets the sky, mountains, trees, cougars, gorillas, architecture, whatever, grass, clouds that move, things that float through the air at different angles, flying saucers, it doesn't matter. Those are all things that are part of the world, not us. So make it clear to yourself that the eye level, the center of vision, the station point, and the projected cone of vision are ours always, the same way, always. The station point can change in our imaginations. We can pretend we're way back from the wall, or we could be an inch away like an ant. We can do anything we want, but the package is the same. It is the eye level, the cone of vision, the station point, and the center of vision. They're always together. They're always a package. They're always on us like a periscope or a motorcycle helmet that has a cross in it and the station point. No matter how you want to think of it, please discern the fact that that is a package that we own. Everything else, all the objects we'll be drawing, all the angles we'll be talking about, all the other things that we're referencing to in the picture and visible and vanishing points and other things that we go to in measuring points, that's all part of the world, not us. So this is our stuff. And then everything else that we have not represented yet in this blank diagram is the rest of the world. So I'm not really that concerned with that yet because my priority was showing you our stuff. And our stuff, again, eye level, always. Eye level, center of vision, our station point now that we're going to be representing there. I no longer have to use this station point with you guys because now you know that no matter what I want to project from my actual head and what I want to pretend that I'm seeing from standing out here in this picture can be equally represented now by that station point because that's me. We're looking from above and we've flattened the idea of myself standing the same distance as I am here, the same distance down now, flattened out, from the picture plane. So I can measure all the angles I want, and that now represents and speaks for me as the three-dimensional viewer. I've just been flattened to become the two-dimensional viewer. Why? Because we're trying to get three-dimensional ideas translated into two-dimensional surfaces, just like the computer screen, paper, murals, a large painting, whatever, a sketchbook, as we mentioned before. So that is why that's very helpful, and certainly a great tool for being able to figure out quick, correct perspective on the fly, as long as you have a little room. And as I said, digitally, at the beginning of the introduction lecture, digitally, it's actually easier to do this stuff because you can create all this room on a layer, do a line drawing at 200 dpi, close it out, make that your bottom layer, and then bump all the resolution way up when you have all your measuring and your perspective work done, if that's what you choose to do. No matter what, this stuff is extremely friendly to that as well. So, okay, the next thing we want to go on and talk about is framing. How do we decide what frames and what context does that work in? So I'm just going to continue with this because I still think the best way to describe this stuff is with no subject matter, and it's almost like a blank stage at the beginning of a play. We're not starting to play yet. The actors aren't coming out yet, and the curtain's not going to rise until we get a few things clear. So I'm the little guy that walks out in front of the curtain and speaks about something. Okay, so we're still at that for another few minutes. The idea here is framing works different ways. Before the camera was invented, which basically becomes us, like we walk around in the world, as I talked about, with this package with us. The idea is traditionally, even though we see like this centered in our own view, because if I'm at the station point here, looking in, with my distance line, or I'm represented by the distance line to the flattened SP person that we're looking at from above, that's the third, we're the third person now looking at that, where we were the first person viewer. If we look at that now and say, okay, traditionally, you have to understand that when you look at the world, we are in fact centered on the eye level crossing the center of vision, and the cone emanates from there. So that's in the middle of the cone. The SP is a particular distance that we choose, always relating to that same point. That never changes. The reason all this doesn't have to be centered in a view is because artists abstract the idea of having to be in the center, and we don't have to be, because we're not moving in sequence like film. We can actually make the frame for a picture anywhere we want. So I didn't center this white piece of paper exactly on everything. As you can tell, I really couldn't make it past my ceiling, and I didn't want to go past here, so I just cut off the border here. So essentially, this represents now our frame, the paper. Well, that's a random choice. So the cone still continues up above into my ceiling here and back down again, as you can see. So what's the point of showing it? We don't need to. We just know it's there. That's all we have to know. The idea is, if this is our scene, I could actually have a whole scene drawn out here. Let's pretend there's mountains here and a river and a little houses and people running from something, whatever. The idea is, no matter what that scene dictates, let's say that stays the same. No matter what that scene dictates, I could actually only show this much of it, because if I'm Caravaggio or a traditional artist of any kind in the past, I can just show you what part of the frame I'm going to cut in and choose to show you the world or the scene through this. The rest of the scene is still there. So what Caravaggio and other painters you like your whole life, before the camera came along and continued afterwards in traditional picture making, before the camera or other than the camera, traditional picture makers can choose any frame within the cone or around it they want and just show the view of what is all there in that little frame. So that doesn't change the world any, we just change the framing. So the traditional way that painters and book covers and commercial art and horizontal and vertical paintings have all been done is that if I want to do a horizontal painting and I don't want to show the 1-point vanishing point, which is always, by the way, at the eye level crossing the center of vision, let's just say we're talking about a 1-point scene generally. Okay, I might only decide to do a picture frame right here as a horizontal landscape painting, and I don't even show the 1 point. It's just off frame to the right. And that's my frame, because that's what I choose to show. Of all this world we can see, or I could choose to show you, I'm only going to show you or choose to draw what I choose in this smaller frame. Or I could do a frame just off center here, or I could still be centered and do a very, very long vertical frame that's very, very narrow and tall. Again, as you can see, my white paper frame happens to be a certain configuration, but it's not centered on this. It is, of course, only a little bit above here and a lot below here, and even goes below the cone of vision. So again, let's make it clear. The camera can't do that. When you're behind a viewfinder, and the viewfinder itself is is the only frame of reference you have in the movie theater or in video games or in your home video camera or your camera or anything that is a camera lens. You have to be in the center of this because the frame is always about being centered around those elements. It's never not, okay? So that's the difference. We are too, of course. Our view in the morning when we wake up is truly centered on those elements, but we can choose because if we're not doing sequential storytelling with like film, frame after frame, moving around things, and they all in perspective move around. In a movie theater, you could do that, by the way. In a camera shot, you could choose to blank out the entire movie screen except a chosen square. Oh, that you could show the whole movie like that. The film rolled, the film took the entire picture, but we decided to mat out everything for the entire film. It would almost be like some kind of cool hybrid art film thing, frankly. Andy Warhol-like. We'll choose to show only a little frame to the entire movie and black out the rest of the screen. That's exactly what Caravaggio, all the traditional painters did, people that did, all the way back to the, antiquity. That's what people were doing. They were just choosing what attempt they were making of showing the scene. They didn't know perspective back in antiquity, but they had some mighty beautiful sculptures, obviously. They had, beautiful tiling work and, everything, and they were still attempting to do this. They were saying, I choose to only show this part of the entire scene, and that's my artistic choice, that's my conceptual choice of a human. We can make those abstract decisions. So once again, traditional work, before we leave it and go to camera film frames in a second, traditional work could choose any view. I could do a horizontal view right here. So part of my view could be out of the cone of vision. Part of it could go way out here and come back. It doesn't matter. They would be distorted out here, as we mentioned. That's going to be distorted out of the cone of vision if you're using traditional 1 and 2 point, that being the horizon and stuff. Doesn't matter. You can frame your picture in your way. I don't want to beat this like over and over again, but I want to make it clear because some people do not understand the concept of why still art, non-sequential art, can just pick any frame they want and just pick a part of the bigger picture in the cone. That's what we do traditional. So remember, traditional means you can make a frame anywhere you want in and around the cone anytime you want, still showing a full picture. That doesn't change your vanishing points. They're going to still behave the way that the scene is designed. The fact is you're picking a frame within it. So in a sense, when you're designing a scene traditionally, a lot of times you really have to be thinking about this and knowing what your vanishing points should be or could be or want to be so that you can make an intelligent, interesting, creative framing choice. That's an artistic choice. It's part of the composition. The very essence of design and the very meaning of it is that the frame and the border and composition is designed into the frame as well as the interior picture. That's obviously, as you know from creating imagery, or if you don't know, your framing choice and your proportion of frame is as an artistic choice as any of the others. So that's why traditionally still single picture paintings and such are basically picking a frame wherever they want. So let's go to film. We're now talking about a camera. So now, since we can't divorce ourselves from actually being in the middle of the viewfinder, just like if you picked up your camera right now at home and walked around with it and jammed your eye into the view frame, you can't suddenly just move over, to the side of the view frame, no more than we can divorce ourselves from the cone of vision. And that's what I'm going to talk about in a minute. There's a related thing with movement with the cone of vision and why there's distortion on the edge that kind of makes sense when you're talking about film frames. So film frames are stuck in the center of the cone of vision, but at different proportions. So if we're using long box, we could be at a really telescopic lens. Why? Because it only selects a little bit of the information because it's telescoping way into the picture. 50 millimeter in lenses is about just touching in a 3x4 frame the edges of the cone of vision. We're going to go into diagrams explaining this thoroughly during the process of the lectures, but I wanted to get to it. Film frames, again, they can be 16 by 9, bigger 16 by 9, huge 16 by 9. We can do 3 by 4 traditionally, larger 3 by 4. All of those would represent different millimeters. So the aspect ratio, of course, with a lens is the 16 by 9 as opposed to 3 by 4 as opposed to 2.39, which is real long box. All those are centered around here, but yet of different proportions. But they have to be centered both in height and width around in the center of the cone. The idea, again, is what do you choose? Now, do they get distortion? We know wide-angle lenses and film do. So again, really quickly to wrap up, Yeah, some of those film frames are so long they come out of the cone at the sides, come back up, especially long backs, and come back out. We might be way out here with our film frame when we're in a movie theater. So the idea is that's great, because if you ever watch a DVD, just freeze frame it during some wide angle shot and you can clearly see the distortion. It behaves very much just like your picture will distort if you draw outside the cone. It's the same thing. So just to hit this information home again and again, there's different choices in framing depending if you're doing traditional, which you can put the frame anywhere you want around here or all through it, or film, where you have to start from the center and grow it out equally. But it can still be certainly different millimeter choices, which will make it the framing larger or smaller centered within the cone, or different aspect ratios, which we basically, again, have traditional 3x4, 16:9, which is basic television, and then long box theater is about 2.39 to 1. So those are our choices. So that pretty much is framing. It's important because a lot of people get confused about this. So let's see if there's anything else I want to talk about. Yeah, it's just, since we're on framing, let's just talk a couple minutes about composition. Since framing is part and parcel to composition, let's just mention that it really is important that you figure out within the possibilities of what we're looking at here and what scene you could create, not only what you draw inside the picture and how you draw it, but what aspect are you showing it to in relation to these ideas in the view. So a cinematographer using a camera for a film has to be very careful because he has more restrictions on, a cinematographer, to say it correctly, has many more restrictions on them than the traditional frame maker, because a traditional frame maker, we can show an old album cover format that's a square. We could show it halfway out the cone, as I mentioned. We can do anything we want. But the filmmaker, because of the low or short vertical and long horizontal they're caught with, they have real problems. They have to get way back to show someone standing at a party, for instance. You have to get like 22 feet back from even to show a full figure when you're in long box. So restrictions come into play. So cinematographers have to be even more precise about how they're showing it. Setting up film shots is a real big deal. It's a lot of work because they have to really think hard about these ideas. And by the way, these ideas we've been talking about, the cone and restrictions and how we look at the world, those all come true for those people, and they have to realize those restrictions, just like we'll be talking about them when we're designing things that are more from a camera view. But mostly, we're probably going to be doing more traditional because that's more the choice of an artist or someone that's making a single view picture. So basically, to wrap it up, we'll be starting diagrams now that just talk about these exact parameters, but we're going to probably start with sketches kind of at the upper left of the page, then talk about maybe the top view with no perspective and an elevation, which is a side view, and talk about, well, what kind of thing are we creating here if we just make a plan of it without any perspective? Then we'll start the diagram. So the typical routine is going to be, what do we want to do? What setup do we have to think about? Are we just doing simple reference figures maybe? Then we won't use a cone and we won't use an SP and we won't measure. Other ones we will. We'll actually get very into it. So it will be all sorts of kind of thinking, but we're always going to be talking about these ideas, even if we're not actually drawing them. And this is I think the big advantage of a good education is it's the thoroughness of how people understand concepts that's important. Whether you use them or speak of them or are constantly referencing them, which you're not always, is irrelevant. The fact is that you know all of it. So again, to wrap it up for this kind of, we're actually going to do some basic shape stuff a little bit too, but it's kind of separate from this. So we'll talk about, in the next segment, we're going to talk about, what is 1 point and 2 point and how to look at a basic cube and stuff like that. It's real basic stuff, but I wanted to go over it before we jump into the diagram so we can still express in real terms in a real space what that means. But to wrap up, the definition part more, it's real important to understand that, again, when you're drawing and doing your work as a drawer or as a designer, you don't have to always refer to all of these rules and put them in all the time. If you just know what you're drawing to because you know perspective thoroughly, then whatever you need is whatever you use, just like that warehouse analogy. You can just do what you want. But people that don't know it are limited. It's that simple. So that's about it for the physical kind of explanation of the terms, but we'll do a little bit of looking at basic shapes turning, and we're going to put the camera actually in front of this, like where it would actually be for a view then for those, and kind of look at some basic shapes. Okay, so great. We'll continue on that in a few minutes. All right. Thanks a lot.